Hey there, JavaScript aficionados! Are you ready to erase your doubts and summon the coder within? That was terrible. But welcome back to another hilarious and educational episode of Conquering the JavaScript Interview. Today we'll be diving into the world of arrays, algorithms, and surprise, maybe some data structures. It's an algorithm today. And we're going to find the perfect pair of some pairs. So buckle up, let's get ready, let's dive on in and see what we're handling today. Right, so like my terrible pun at the beginning implied, we are finding some SUM pairs. Right, a function that takes two arguments, an array of integers r and a number n. This function must return an array of arrays that show each pair of numbers from the input array that equal the sum given, right? So given an input array of 1, 2, 3, 4, 5, and a sum value of 6, we should return an array that has a set of numbers. So there is the returned array. The first array is a pair of numbers, 4 and 2, that come from the input array that, when added together, give us the value of 6. Then we have another possible value of 5 and 1 that come from our input array, and no other combination of numbers gives us 6, which means this is now done. And presto, that is the goal of find some pairs. Now, we should be able to also handle a couple of different scenarios. For example, what if we have some negative numbers? Hopefully the logic won't be any different whatsoever to handle this particular problem. Where if we have negative numbers and say a sum value of 0, we have two pairs of numbers within here that can handle that, which is negative 3 and 3 and negative 2 and 2. Easy enough. We should also make sure that we don't have any errors occur should we have an input array with a sum that can never be reached. For example, this here of 1, 2, 3, and Shivon. And we also have one of no input at all, should also not give us any kind of false numbering happening here. So we're going to make sure we have some edge cases covered, and we're going to make sure that we can handle the actual code itself, and maybe they will be one and the same, we shall see shortly. So given this, remember I'm slowly building up a suite of tests and things like that using Mocha and Chai so y'all can get a handle on this. I'm still debating on how I want to structure and organize it, but then again, I could always just keep on updating it because welcome to development. It's a journey, it's never a destination. So yeah, to handle this one, before I begin breaking it down into code, let's imagine we're at a party. Well, I mean, we're all sitting here on YouTube and watching me talk about code, and we're all trying to learn together, so I guess we're the party. Let's imagine we're at a party together. You know, all of us in the comments are at a party together. We formed our own party, all right? We're at a party, and we're trying to find pairs of people whose combined height equals a specific number or some other specific height, which is our input value of n. All of us at the party are the array of original inputs. So we're going to have one of y'all or myself, some representative of the group, is going to walk around with a clipboard, and they're going to write down the names of the people they have encountered as well as their heights. So for the first person they encounter, they'll be like, what's your name? What's your height? Got it. Thank you. And they're going to walk through this party, and for each person that individual meets, they're going to look at their clipboard and to see if there's somebody they've seen before whose height combined with the person they're talking to right now would go, oh, that is a pair that gets us the number we're looking for, and they're going to write down that pair as a match. By the time they've gone through and met everybody at the party, they're going to only have a list left of pairs that combined together gives us the desired height, our n. So with that in mind, let's go ahead and get our individual with a clipboard going and beginning to write down heights they've seen and being able to add new heights they see to previously seen values to see if they equal the height n we're looking for. And like I said, by the end, we should wind up with a clipboard full of paired names. Okay, so let's go! As always, we're going to dive on in-ish, as guy that's 4 minutes in, where we're going to begin coding out what we're looking for. So, like I said, we need to first off have some array that will act as our array of pairs. We're going to be pushing in new subarrays into this pair array that's going to be returning and probably console logging for visual purposes. So we'll say return our pairs once we're all done with our logic. And let's just console log that as we go through this to make sure that it looks somewhat decent above my fat head here. Right, so like I had said in the analogy, we need to go through each person at the party. That sounds like a for loop here, right? So we're going to go through each person at the party. And in the previous video, I mentioned this. And every other video, I think I repeat myself a lot, which is, you know, if you can use some shorthand here or there, go for it. Sometimes I like to stick it through with a traditional for loop syntax to show you what that fundamental looks like. Let's keep it with a shorthand today. So we're going to say each, my goodness, num of the array. So we know we're given an array of integers. We're going to go ahead and do that there, which FYI, if you wanted to, you could throw in some kind of sanitization here. Like, so edge cases here, we could, like if we're trying to wow our interviewer and really kind of add extra stuff here, we can say if the type of num is like not a number or something like that, that we can throw an error saying, hey, you're giving us an array of non-integers or something like that. Right, so if we don't get numbers through this thing here, I'm pretty sure that's a type, right? Right, type of number with double quotes is what I meant to say there. There we go. I was like, that doesn't seem right because number would be a variable. It's number in quotes. So you could do some kind of type checking like this where you look for its number, or you could also even do the same up here. You can say if n is not a number, then send it out. If array is not an array of numbers, send it out. So you could do some edge cases by adding if statements at the beginning to throw a helpful error message early, for example, if the inputs are not correct. But those aren't really... Those are good edge cases that you would have on a website, but throwing it into an interview is like if you're really looking to, if you can't think of edge cases that you would have to encounter yourself, then you can always do some input sanitization to show that you can think ahead and things like that. But coming back here, right? Remember, we kind of learned this trick back with the not cumulative sum, but there's a previous one where we had to find a sum of values inside of an array. That's right. It was the missing integer, which I'll have to remember to add into the description down below, a link to that previous one that will show you a little target thing I did to find a missing number in a given value, which we did by simply taking our desired value and subtracting what we're looking at to see if that's what our target value is, which means we can find what our target number we're looking for is by looking at our sum, the one we're looking for, represented by the input value n, subtracting what we're currently looking at in our array of inputs, and that is our target value. Meaning, we need to say, hey, have we encountered this target before? So basically, this is us saying, this is what we're looking at right now, and does it exist in our clipboard, which we haven't coded yet, right? So our clipboard is going to be done via this right here. Now, we've done sets in the past. Sets are, again, arrays that simply do not allow duplicates, with some changes as well. They have methods to access their values and check their values and things like that. We're going to be doing that here, and that'll allow us to not have to write any kind of additional logic or conditions to handle duplicate scene numbers, because again, that's why we're gonna handle that problem here with this set value, right? Yeah, that way we now have some handy dandy methods on our set here in order for it to see if we've encountered this before or not, right? So we're gonna say if our scene number set already has our target, meaning, hey, the individual we're looking at, subtracted from the sum height we're looking for, if that target value exists on our clipboard, that means we have seen somebody else at this party with the desired height to combine with our current guy or gal or non-binary person right here in num. Then what that tells us is that we have seen somebody that added to this individual gets us to n, right? Because that means that our target plus num would then equal n is another way of looking at this logic here. The target we have on our clipboard somewhere, plus the person we're looking at, gets us our desired height for this little party experiment and analogy I've been using here, which means, aha, we've got a pair. And that means this if statement, when true, can say, hey, pairs array please push in a new array, a subarray, of our current number and the target we've seen. And that right there will give us a pair of numbers when added together to get us our n. Otherwise, we simply do nothing, right? There's no else statement for this. But we will say every single time we go through this, we should probably take our scene numbers, our clipboard, and add to it the current number. So that way, if we haven't encountered this number before, we simply add it to our scene numbers. Duplicates will not be added because that's how sets work. So that's how we can avoid that problem entirely. And then honestly, once all that is set and done, that should be it, folks. Once we have gone through everybody at the party, aka our iteration of our for loop completes, we should be left with a set of numbers or people, individuals that pair together to get us our desired n value, and that should be it. Hopefully, let's go ahead and give her a whirl here, right? Like I had said, let's copy this one right here and see if we can call it and get our desired result of 4251. Now it depends on how we iterate through our array and how it pairs these together. The order might be different, which will be annoying for comparisons and testing, as I've learned. But ultimately, as long as they're correct, I don't really care what order they're in. So let's fire away, see what happens. Yep, we got our desired result. 4 and 2 get us 6, 5 and 1 get us 6, and there's no other set of numbers in here that end up getting us the value of 6. That's what I like to see. Let's see if it works with negative numbers. Another fun test here. Boop. I'm going to then save the file. Talk about your all-time backfires here, folks. Oh, I have a syntax problem. I have too many parentheses sets. I was like, that's weird. That shouldn't cause an issue. Try that again. Let's clear the console as well. My bad there, folks. I know I've said this in my full stack curriculum videos, like in Gravity, in my company's Covalence's course, right? That I personally don't like really pristine videos that have their errors cut out, because that's not how real development and coding is. You make dumb mistakes. You don't get, you get less freaked out the more you see them. You just get better. You don't get better at not making mistakes. You just get better at handling them. So I saw that it was not recognizing my input array, and I was like, that's interesting. And then I realized I had an extra set of parentheses down there due to my copy and pasting. So yep, that's what happens. But nevertheless, like I was saying, this code is totally fine and it works as it should. We get -3 and 3, which indeed gets us 0, -2 and 2 gets us 0, and no other combination inside of here will get us a value of zeros. Now, is my code as handled could it handle a situation where there is no possible values? Yeah, and it returns that empty array. We had that handled right there. There's no weird undefined, null, or error type object. Just gives us an empty array, which we'd have to test for with a .length anyway. And let's see what happens if we give it an empty input array. Is any kind of weirdness going to go on here? No, it just means it's going to loop through nothing and return nothing for us. And there you go. Now that output is not because we had an input array of empty. Remember, this empty pairs over there that I'm looking at in our code base. So yeah, that about solves this one. As a quick TLDR, what we've done here is we've created an empty array called pairs. It'll store the pairs of numbers whose sum is equal to the given number of n. So that's going to be our returned value. We create a new set called scene numbers. This is where we store those numbers we have already encountered in the array. The benefit of a set is that it doesn't allow duplicates, which solves that major problem for us. We then iterate through the array right here, no problem, using a for of loop or a traditional loop, whatever you want to do. This just saves us some shorthand with some variable naming here. We calculate the number by subtracting our desired total n minus the current number we're looking at. That gets us the target we're going to be looking for in our scene numbers set. If we have that target in our scene numbers set, that means that our current number we're looking at plus the target together get us our n, which is why we push that into our resulting pairs array. And then as we go through, we add each number we've seen to our scene numbers set. And again, because it's a set, it won't add any duplicate numbers for us to save us the hassle. Then we simply return that set of pairs and we are good to go. Right. So that is a complexity of big O of n, right? That's just a linear thing because Yeah, that is just our linear line right here, this big O of n. The bigger the input array gets, the longer we have to loop through it, even though we iterate through it only once, thankfully, in this particular solution. And it gets us a big O of n, and it's the same thing for the space complexity. It's the same. It's a big O of n, because the set will also, the larger our input array grows, the larger our set of C numbers will also have to grow at the same time. So this is a fine solution. I mean, I think it's very legible. It's easy to understand. Big O of n ain't terrible. It's just linear, right? The bigger the input, the longer it takes. But it also has a space concern. So, like, if you're interviewing for a more advanced position, they may consider, well, could you possibly show us a solution if space was of a concern? So that actually changes how we're going to be able to attack this particular problem here. So, like I like to do occasionally, without, like, I wouldn't have time in the day to show you 50 different implementations of the same thing with different concerns and things like that for every possible question. But let's see. We'll call this find some pairs set, because I'm going to have a new one come down yonder called find some pairs, where I'm going to do the exact same logic. I want to see if it ends up working the same way. So just like before, as the set grew, we would have an issue with our big O notation because the space would also grow there as well. But we can actually, we could take a sacrifice on performance and improve our space complexity by not using a set at all and instead switching to a double nested for loop, which we know, again, that is a big O of n squared. And anytime you have a nested for loop, it's always going to be n squared, which you can see there is the bigger the input gets, the worse the optimization gets, the performance gets, because we have to run n squared operations on every single value of that input because we're looping through a loop. Now, in order to solve this one, we're still going to have our pairs eventually generated. There we go. And we'll console.log our pairs as well to make sure that we're looking at them correctly. I'm going to collapse this really quick. I'm going to go back to our original call of this value here. So we actually have an expected return array coming out for us. And here's how we're going to handle it. We're going to have, like I said, two nested for loops. Like that is going to be our structure. The outer for loop is going to go through our array. The inner for loop is going to simply go through all the values after the index position we're currently at. So basically, we're taking each element and looking at every single other item in the array for comparisons here, right? They compare all possible numbers in the array. If there's a pair sum that equals the given number n, we push that pair into our results. So then we're going to be looking for if the two numbers together add to get our sum n, then we push them into the pair array here, right? So here we go. This, for the sake of understanding how it works, I am not going to use shorthand on the outer loop, so you can see what I have to do on the inner loop. That's what we're going to simply say, just move one ahead in the same array and loop all the way through it. And this is how. No typos this time around. Yeah, this is how we're going to compare every single element to each other in the array until we find the pair we're looking for. So we're going to say if the array what we're currently looking at compares and sums with every other possible number in the array, if the two of them together give us our n, then we're going to say, hey, pairs, push in a new array with the element from the array at I and the element at j right there. I had a typo in a previous video someone called me out on where I wrote RB instead of RA or something like that in one of my comparisons, but hopefully I got it right here. So yeah, that's what we have to do in order to do this particular solution. And if I save it and console log it, yeah, we get 1 and 5, which is 6, and 2 and 4, which is 6, which is indeed our given solution right here. So yeah, again, like there's pros and cons, right? Like this is definitely harder to read than our previous solution up here. But it also performance-wise is worse because it's an n squared, big O notation for complexity. But in terms of space, no additional data structures are used or needed. So I think that's just an O of 1, meaning it's just a static good to go, right? No problem right there. It's definitely harder to understand. And that time complexity, as the larger the input gets, the worse. This one gets worse way faster than the first solution. So if space was an issue, this would be what you would want to do and take into consideration. And if space is not an issue, then the scene numbers is a faster performance and much easier to read and understand. So even if space was kind of an issue, you might argue that because of the readability and maintainability of this, you'd want to set with that anyway. So again, it really is just about understanding that there isn't really always going to be a this is the way to do it type answer. It's always going to be in a list of pros and cons or trade-offs is what I tell my students here, right? So what else? What else can I think of? What do my notes say? Yeah, so we talked about Big O. Why is it cool? Learning about trade-offs between time and space complexity. That's kind of like the gist of some coolness behind these two implementations. Just shows you how you can optimize your solution based on whatever constraints you're given in an interview or more than likely in a real-world scenario, right? Again, practicing these algorithms and handling this common interview question and being able to solve problems with efficiency in mind can be highly valued by your interviewer to say that we are taking a look at it. Hey, Percy, come say hi. My cat Percival is right in front of the camera, as y'all can see his head right there. You want to come say hi? Come here. He's in all my thumbnails. You'd think he'd be more in my videos here, so that way in my thumbnail for this video, I can then say, actually is in the video for once. So, come here. Come here, bud. He's playing coy. Want to say hi for the camera? He just sniffed it. Good boy. Yeah, so with Percival's sign off right there, again, y'all, thanks for watching. I hope you found this video helpful in our journey to become a better developer. If you enjoyed this video, consider giving us a subscription, hit that bell notification, give us a like, send a comment down below. I'd love to hear your thoughts on alternate solutions to this beauty I saw right here covered in the video. If you have any suggestions for alternate or more efficient ones, throw them out in the comments. I love checking it out because, again, the whole purpose here is to be constructive, positive, and help keep the discussion going by helping each other get better, which is why I love teaching. So thanks again for tuning in, and I'll see y'all in the next video. JK, I don't think I ever ran any kind of test on these here. Let me rename it here, because I wrote the test. I might as well give him a whirl here, right? So I'm gonna go back to the one that's clear and easy to read here, and I have my tests set up as well to take a look at them. Let's see if my npm run test ends up working. Hey, although there's a bunch of weird. Oh, those are previous ones here. For passing, what am I console logging something? Oh, in my in my function itself, there's console logs all over the place. So, yeah, we get our 4 tests passing right behind my head here, where we get returns an empty array when no pairs are found, returns an array of pairs that add up to the target number, no problem, handles negative numbers and 0, returns an empty array if the input value is empty. So there you go, all tests passing, and again, keep watch for a video and a link in the description when I finally have a repository ready to go along with what I'm doing here. So later.